Welcome everybody. As Mark said, my name is Brian Grett. I'm up here in beautiful Portland, Oregon. Very dry, comparatively, Portland, Oregon at the moment. And I'm going to be talking to you today about the basic aggregations inside of DAX. My presentation is somewhere out there. I hope people get the reference to American Tail. If you don't, it's a sequel thing. That's fine too. Okay. Hey, let's go look at the next slide. Because I'm tired of looking at my face. Let's talk about DAX aggregation functions. So the good news about DAX aggregation functions is they're easy to work with. And what do I mean by that? Well, if you've got like some measures, right? Maybe you've got total sales, last sales date, total units, average customer age. All of these are calculations that can work with very simple aggregations. Simple, I mean things like sum or max or average, the same kind of aggregations that you would use in Excel and are probably familiar with if you are an Excel user, right? And to work with them in DAX, it works a little different than Excel, but not very, right? You type in the name of which aggregation you want to use, whether you want to use a sum, whether you want to use a max or an average. And then inside the parentheses, instead of typing a range reference in Excel like A1 to B29 or something like that, what you do is you type in the name of the column that you want to aggregate. So if you've got a sales table and it's got an amount column in it, you say, I want to go sum up the amount column in the sales table. For Excel folks that have worked with Excel name tables, this looks even more familiar. The syntax is the same thing. However, a lot of people in Excel don't use name tables, and that's just fine. Suffice to say, it's pretty easy to do. You just type in the name of the aggregation you want and which column you want to apply it to. Easy peasy. So that's the good news. I don't want to call it bad news, but less good news is understanding how these things work is just a teeny bit trickier. I don't want to call it really difficult, but I will say that things probably work quite a bit different than you think, and understanding how they work is going to help you when you try and go do not even advanced DAX, just intermediate DAX. If you want to get good at DAX at all, if you can understand the mechanics of how these things actually function, what to do, it's going to help you out a lot. So in this presentation, we're going to look at how these things work, as well as the basics of how filters from slicers and other things get applied so that you can arrive at the answer that you are expecting, right? So you see a number that you say, hey, that looks like the right number to me. I clicked on some slicers. I wrote a measure. How did I get from A to Z? That's what we're going to show you in this presentation. In fact, we're going to show it to you twice. Okay. I'll pause. Any questions so far? Springfield, Missouri. How about that? Drawing a good crowd. Dig it. Okay, so let's see. In the first section, I will introduce and walk through these concepts at a slightly higher level, where I'm just showing a few pieces at a time. Then we're going to sort of hit the rewind button, go all the way back to the beginning and show it to you again, but we're going to show everything on the screen at once. That way you could see all the pieces and how they work together. Okay, so you're going to see the exact same calculation twice. Get ready, it'll be fun. Maybe. Think so. Okay, so what are we going to learn today? I'm going to show you some stuff on this slide that's going to make zero sense right now because we're at the beginning of the presentation, not the end of it. So here's those four things that don't make any sense right now. The first thing you're going to learn is that aggregations work with copies of the raw data. Second thing you're going to learn is that relationships allow for a mega lookup to VLOOKUP columns, which is going to allow for the filtering of that copy. Third thing you're going to learn is filters in DAX are tables whose rows act as a list of values to keep for a given column. Last thing you're going to learn is the final sum or min or max or average or whatever gets done on the copy of the table rather than the original, right? For folks that are deep programmers, when I say copy, think logical copy or view. For everybody else, which I think is most folks, if you're an Excel user, I come from an Excel world, just think copy. It's the right way to think about it, okay? All right, that's what we're going to learn. And I would ask questions, but you're not supposed to know this stuff yet, so you can't have questions, except for typos. I don't want to hear about typos. I already do too many of them. If I take questions about typos, it's all we'll talk about. Okay, so in this particular presentation, we are going to have two tables we're working with, right? The first, from an Excel document, we can imagine being called sales transactions, has sales transactions for a restaurant that will probably go out of business soon because there's only 7 sales transactions, but that's okay. These are the sales transactions for our restaurant. And for each transaction, we could see the shift that it happened in, whether it happened for lunch or for dinner, the quantity of whatever thing was ordered, whether somebody ordered 2 or 1 or 3 or something, right? The sales revenue amount, whether we made 20 bucks or 8 bucks or 24 bucks, and lastly, which dish was ordered, right? So we could see if somebody ordered pasta or a burger, okay? That's table number 1. Table number 2 is from an Excel document called dish lookup, right? And this has all the dishes on our menu. So we got 1, 2, 3 rows because our restaurant sells 3 dishes: pasta, burger, and salad. And for each dish, we have whether it was a regular dish or a house specialty. The house specialty for this restaurant is a burger, which is not usually a good sign, but that's the way that it is. We also have the pasta and the salad, which are both considered regular menu items, okay? Our items on the menu can have a gluten-free option. So we see that as well. It turns out the pasta, unsurprisingly, no gluten-free option. The burger, we'll throw that on a gluten-free bun for you or put it in a lettuce wrap. And the salad, we'll just take the croutons off. So those could be gluten-free as well. We also have, we're not really going to use it, but we have the unit cost of each one of these items. This is an estimate of how much we think it costs us to make a plate of pasta or a hamburger or a salad. We won't use that here, but that's the data that's in there, okay? So I'll pause. Any questions about what we're doing so far or what we've got? Feeling pretty good? Okay. I will point out, if this were not a Power BI user group, but an Excel user group, the first thing everybody in the room would be thinking to themselves is, hey, I see a dish column over here. I see a dish column over here. You know what I'm going to do? I'm going to go grab my VLOOKUP function, and I can use VLOOKUP to go get this information in this table. That's a good thought. Hold on to that thought. We'll come back to it. Okay. This is the data we're working with. Okay. All right. So let's imagine we're going to use the Get Data button inside of Power BI to load both of those workbooks into the data model in Power BI. So what do? We go into Power BI, we hit the Get Data button, and we load the first table and we load the second table into Power BI. So this is the tables as they exist in the data model inside of Power BI. This is sort of the raw data. Okay. So let's see. Okay, no comments there. Okay, great. So let's take these 2 tables down here, and let's just kind of simplify this and shove them up here just so we could simplify our page a little bit. Okay, there we go. So this is our data model. This is the raw data we have to work with in Power BI. We got the sales table that has all the sales transaction and the dish table, which has all the dishes on the menu. Okay, so once you loaded that in Power BI, if you've used Power BI at all, you know what your next step is. In Power BI, you don't have VLOOKUP, you have relationships. So in Power BI, what would you do? In the model viewer, you would drag one of the dish columns on top of the other to create a relationship. What does that look like? You'd find a screen that looks like this, which I refer to as the International Space Station. Looks kind of like a big old spaceship, right? You'd hover over this dish column and drag it onto that dish column, or vice versa. You could grab this dish column and drag it onto that dish column. And when you did that, what you would end up with is a relationship between those 2 tables, okay? That's how it works in Power BI. And once you have that relationship, right, this creates what we might call a lookup relationship between those 2 tables, right? What that means is from the sales table, we can look up any information from the dish table, right? So if I have any of these transactions, I know what dish it is, pasta. I know whether that transaction was a regular type or house special. I know whether it was gluten-free or not, okay? So this lookup relationship, another name for it is a many-to-one relationship, right? For each one value here, pasta, burger, or salad, there are many values over here. That's a good way of thinking of it if you're used to it, but I'll point out the reverse side of that coin is that this is a lookup relationship in this direction. We could take any transaction here in the sales table and look up values from over here, okay? So ignoring the how for a moment, which is what we're going to get to, enabling this relationship by dragging the columns on top of each other is what's going to allow us in Power BI to put a slicer on type or gluten-free option or even dish and have that filter that we apply over on this table flow down the relationship. And okay, so we have, where the heck was I? We have a lookup relationship from the sales table to the dish table. Hey, you guys weren't expecting that at the start of the meeting, were you? Okay. We always keep things interesting here. So if we ignore the how for a moment, this is the functionality that's going to allow us to place slicers on any of these columns and affect aggregations over here. This is sort of the magic of Power BI. Once you turn on these relationships, you don't have to worry about how. you don't even have to create a measure that uses sum. You could just drag the amount column onto a visual and slice and dice by any columns over here and have it affect those aggregations. Works like magic, okay? So, let's see. I want to note before we go much further that we have a lookup relationship between sales to dish. We do not have a lookup relationship in the opposite direction. If I know what dish I've got, I can't tell you what shift pasta is related to, because pasta can be sold for multiple transactions. So the lookup only goes in one direction, okay? Which is why, by the way, in DAX, the filters only flow from the one side to the many side, if you've heard that. It's because the lookup flows in this direction. We'll get to that in a second. Okay. So I'll pause. Any questions? Feeling good? Okay. So regarding column names, right? Regarding column names, when you look at your model tables in Power BI, what it's going to show you is the shortened names of those columns. However, the real names for the columns are actually quite a bit longer, right? So here in Power BI, where you see the names that look like this, the real names look like that, okay? They don't show them to you this way, A, because it would take up a lot of room, and B, it would be confusing to folks. However, these are the real names of the columns. It shows the name of the table, then in brackets, the shortened name. This is often referred to as the fully qualified name, if you've heard that term before, okay? These are the names of columns that you type into DAX formulas, and also these are the names that DAX uses internally to figure out which column we're talking about. This is handy because if we have two columns named dish, if you look at the fully qualified name, you see that the names are unique. Every single column has its own unique name. Okay, good. So, let's go move those over there. What I want to do is let's imagine that we create a measure called total sales, which is a simple sum over the sales amount column. And as you type this out, most folks think to themselves, oh yeah, the sum of the sale amount column. Yeah, that looks like that one right there. Yeah, it even says sales amount. Okay, good. Okay, so you type that in, you drag it onto a card. Then maybe you add some slicers for type and gluten-free option over there. And sure enough, when you click on regular, the number drops down from 110 or whatever it was a minute ago, 110, down to 62, right? Now, if you get a calculator out, sure enough, if you look at just the regular dishes, which is pasta and salad, if you just look at those rows, and it does indeed add up to 62, the question is, how do we get to that number, right? What mechanically happened? Let me show you. Okay? So, when we do that aggregation, there's going to be 4 steps that happen. 4 steps, okay? The first step is we're going to get a full copy of sales. The second step is we're going to perform what's called the mega lookup. The third step is we're going to apply each filtering table. And the last step is we're going to aggregate the sales amount column in that new table. Okay. So for the tactical folks in the room, if you're not used to these terms before and you're thinking, is this like a similar concept I already know? Here where we're getting a full copy of sales, if you've heard the term a table value before or a temp table based on native columns, it's the same concept, but we're just going to talk about it as a copy of sales, right? If you've heard the term table expansion, or if you've heard the term left outer joins before, that's going to match very closely to what we're going to call the mega lookup, right? And lastly, when we apply each filtering table for the SQL folks in the room, this is going to be a natural semi-join or a set of natural semi-joins. If you are not a SQL person, you don't need to know any of these concepts. This is designed for Excel folks, which is where I come from, okay? Okay, and there's no technical terms for this fancy one because it's just a sum. So let's see how those things actually play out. Get a full copy of sales, perform the mega lookup, apply each filtering table, and aggregate sales amount in the new table. Let's watch that, okay? So the first thing to know about DAX is that it always works with copies of the data. And the sum aggregation starts by getting a copy of sales, full copy of it. So that right there, we're going to make a copy of it. And it's going to look like that. Now, this table here, a table in the data model, is sort of your raw data. This is a copy. I refer to this as a temp table in a lot of my videos. This table only exists temporarily, just long enough to produce a number, which is why I rendered a little bit different. So you could tell the difference between the two visually, okay? So sum starts by getting this copy of the table, right? So what does it do with it next? Well, once it's got this copy, DAX is going to need a way to apply any related filters. In particular, this filter on type equals regular, okay? So how's it going to do it? It's going to perform the mega lookup or table expansion, if you like that term better. I like mega lookup, right? It's like a VLOOKUP, but mega. It's bigger, right? So what's going to happen is because we've got this sales table here, and we have a relationship between these two, I can use the value here in sale dish to go look up all these columns over here and drag them all in. So as opposed to a VLOOKUP where you might do one cell or one column at a time, this is going to bring in all the values from dish. And it's going to look like this. If you've heard the term table expansion before, it's the same thing. If you've heard the term left outer join before, it's the same thing. But basically, we take our initial copy and we kind of stick on the end all the additional columns from our lookup table over here, right? And notice the name of these columns have these big, long names right there. So you could tell just by looking at a column which table it originally came from. Okay. I'll pause. Any questions so far? How are we feeling? Feeling good? All right, I'll take it. Okay, so
carry on. Thank you, Brian.
I'll take it. All right, so we got the copy, right? And the copy was this guy right here. We performed the mega lookup to get all these columns on here. So now I want to point out in this example for the quote unquote mega lookup, a name for it, right? There was only one lookup table attached to sales. A very common scenario in a Power BI model is that your transaction table, your sales table, will have several lookup tables associated with them, or maybe just 6 for this particular example. Let's say you had 6 of them. The mega lookup would go get the columns from all 6. So if you had 6 lookup tables and each one had 10 columns in it, you'd be adding 60 columns onto this copy. Sounds like it'd be really slow. It actually works really, really fast. So the reason you hear the term table expansion is because the table's kind of inflating like a balloon, right? Oh, but you know, if you're an Excel person like myself, mega lookup, same idea. Okay, so now that we got these on here, what are we gonna do with them? Well, this is where the filters get applied. And here's where we get to our first thing that tends to throw people for a big old loop in DAX. Okay, so what's interesting is that in DAX, filters are tables. So this here where we click on regular on this slicer right here, in terms of DAX, what that slicer produces is a table that looks like this. Right, single column, single row table. The column name is dish type, and the value in there is regular. Okay. Now, this is really confusing for humans. However, for databases, this both makes complete perfect sense, and also, particularly because of the way that data is stored in Power BI, this will run a whole lot faster than other things you might do, such as a where clause, if you're familiar with that concept. Okay. So why are tables, or I should say, why are filters in this weird table format? Why not just say dish type equals regular like a normal person? Because the database has to do the filtering, and DAX wants that database to be able to do it nice and fast. Okay. All right. So that's why the filter is a table. But how do we interpret it, right? What does it mean that this is a filter? What actually happens down here? So let's see. Okay. So what DAX does is if it knows that this is a filter, DAX is going to check to see if the filter has any common columns with the copy of the table we're working with, right? So if we look at this table right here and this one down here, are there any common columns? No. Oh yeah, right there. There's a common column. This column right here, dish type, that appears down here, okay? So what does it do with it? Okay. So the filter acts as a list of values to keep. So because this table only has one row and so it only has one cell with regular in it, basically the way that this is interpreted as is I only want to keep the rows down here where the dish type is equal to regular. So it filters out anything but regular, in this case filtering out all of the how special rows. Okay. For folks that are very familiar with DAX, this is called a semi-join, or it's almost like an inner join. But you don't have to know either of those things. All you need to know is when this is a filter, it says only keep the rows where dish type equals regular. That's what that means. Okay, so these rows get knocked out. Kaboom, there they go. All right, and now, if there were more than one filter, like if somebody clicked on gluten-free, no, or yes, it would just do that exact same process for each filter, check to see if there's common columns, and only keep the rows where you match the value. And it just does that for all the filters. And then when it's done, we're almost done with our aggregation. What's the very last thing it does? Finally, with all that filtering done, the very last step is to sum up the sale amount column in this table here, right? Not the one that we loaded originally, but this copy where we added all the columns and added the filters. The reason being is the one in the model, if you were to add up all those values, you get too big of a number. Here, if we add up all these numbers, we will get 62, which is the answer that we want. Okay, and that is how basic aggregations work inside of DAX. Okay, so let's review those steps one more time. So how do we get to this number again? Because we got this formula up here, sum of sale amount. The sum function got a full copy of sales. It performed the mega lookup to go add all those columns to it. It applied each filtering table to just keep the rows that matched what the user wanted. And then when it was done on that copy that had been mega looked up and filtered, it summed up the sale amount column in that copy of the table right there. That's how you get 62. Okay. Questions about that so far? If this is still a little fuzzy, we're about to see this exact same thing again from start to finish. If you're already bored by this, I have bad news. We're about to see this thing again from start to finish, from a slightly different perspective, though.
So, Brian,
any questions?
There are just two questions that are posted in chat. One is from
Oh, yes.
Is mega lookup the reason we're encouraged to have multiple dimension tables with related columns rather than one mega dimension table and one fact table?
There's a couple reasons for that. That is one of them. The other reason is when you are working with DAX, there will be a common scenario where you manipulate the initial filters, and you might want to do something like get rid of any filter on a product column, let's say. And if you have one big dimension that has columns for products and customers and stores and dates, well, then it becomes very difficult. You have to enumerate every single product column in your DAX code. If you have one table that has all of the columns for products, it becomes very easy to say, I want to, in my DAX expression, get rid of any filter on products. You just say remove filter products. It'll keep all the filters on other tables, and it'll get rid of all of those. So like those are the sort of two big reasons. It ends up performing a little bit faster, actually considerably faster. And in my mind, more importantly, it allows you to clear filters selectively. Also, if you have more than one fact table, it's usually going to be easier to conform fact tables to separate dimensions rather than one giant dimension. Okay, let's see. Oh, yep.
Okay, great. And one more from Nandan. What are the query memory implications of this table expansion? This
pretty minimal.
Earlier question.
Yeah. So there is a slight difference in terms of what you are asking DAX to do versus what it does internally. So when you think about this join, you could think of it as a logical. So for the technical folks, you could think of it as a logical expansion where logically we're adding all of these columns. It doesn't actually have to materialize all of them. If you want, again, excuse my technical mumbo jumbo right here. So DAX is smart enough to know that if you actually end up needing to use 2 or 3 of those columns, when it actually goes and does stuff inside the database, it's smart enough to only grab the stuff that it needs. But when you're thinking about what it's doing, it's best to think about grabbing everything because it'll help you visualize certain behaviors that you get if you start using functions like calculate to manipulate the filters. If you get too mired into how DAX is optimizing the code, you will actually confuse yourself. Think about it just grabbing everything. You're very welcome. Any other questions out there? They can be in chat or you can hop on mic either way. Okay, so let's do that again. Now one more time. Now we're going to look at that exact same process again, but this time we're going to try and keep all of the relevant information on the screen at the same time. Last time I was somewhat selective to say, let's just keep the little bits and pieces that we need. Now I want you to see all the working pieces at once. There's no questions or ambiguity around it. For folks that have followed me before, we're going to use what I call a DAX sketch to do this. This is a method that I have built up, which I use to illustrate DAX concepts. If you watch my other videos, this stuff will look very familiar. If you haven't, this won't look familiar at all. But hopefully it'll be easy to follow along with. Let me know if you have questions. Okay, so let's start by building this thing up from scratch. We've got a data model where we have a sales table and a dish table we talked about before, where we have a lookup relationship, a many-to-one relationship from sales to dish. Okay, we have a measure called total sales, and it's just the sum of the sales amount column. Okay, if you're doing real good right now, you know that when we sum up the sale amount column, we're not actually summing up the sale amount column here. We're going to sum up a copy somewhere down here. But if you're still fuzzy on that, that's okay. Okay. We also have in Power BI a card where we drag the total sales measure onto it, and then we added these 2 slicers. We clicked on regular, and we got $62. And if we were to get out a calculator and just look at the regular rows for pasta and salad, we indeed would get $62. But again, we want to find out how DAX is doing this. So let's see that. So this is my frame. And when I do a DAX illustration, I create little frames like this. This is where all the stuff happens, okay? You can think of this, if DAX were a game, this would be the game board where all the pieces go, okay? The very first thing DAX is going to do to set things up is add all the initial filters, right? It wants to get them all in place before the formula up here runs, okay? The place that it adds them is what's called internally the filter context. I'm just going to put them up in the corner right here. So what do I mean by that? Well, before anything runs, DAX says I got to go add all the initial filters. The user clicked on this slicer right here, so this is going to get added as a filter right there. The filter context, which is all the filters that are active at a given moment, has one table in it, and it's got dish type equals regular in there. Okay, cool. So now that we got the game set up, the board is ready to go, DAX is going to start running the formula in our measure here, right? Well, this formula is quite simple. It's got one function pointed at one column. However, that hides a little bit of complexity, which we just saw. So let's go see how that works, right? So we're going to put sum down here because that's the first thing that happens. This icon indicates that DAX is using the sum function. The icon is a camera because when I draw these things out, I like to use the camera icon to indicate that we're going to take a picture or make a copy or evaluate a value of one of the tables in our data model, okay? So what's involved in running that sum function again? Brian, I already forgot. Don't worry, I remember. Actually, I don't, but the PowerPoint slide does. We got 1, 2, 3, 4 steps. We're going to get a full copy of sales. We're going to perform the mega lookup. We're going to apply each filtering table, and we're going to aggregate the sale amount column in that new filtered copy. Again, the first bit is like a table value or a temp table in native columns for technical folks. The second bit is called table expansion or a sequence of left outer joins following those relationships. And the last bit is a collection of natural semi-joins. If all that sounds like gobbledygook to you, doesn't matter. As long as you got the big names, that's what I care about, okay? So let's start with step 1. Seems reasonable. It'll keep us from getting confused. We're going to get a full copy of sales, right? Well, there's a sales table. What does that copy look like? Like that. We just made a copy of it. It's in this kind of funky format because this is temporary. The copy is only going to be around long enough to get that $62. Okay. So that's it for step 1. That was easy. Step 2, perform the mega lookup, right? Well, what's the mega lookup again? Well, we have a relationship between sales and dish. So if we have any particular row in sales, we can look up all the stuff in dish because that look up relationship right there, we can look up that direction. So we can get all these values into our table through sort of a giant set of VLOOKUPs or left outer join if you like that better. So we're going to take all this stuff and shove it down there just like that. Easy peasy. Okay. So now we've performed the mega lookup. I want to add that the different kinds of columns in here have slightly different names, right? So the columns that come from the original table have a different terminology than the columns that come from the lookup tables, right? These are called native columns because they come from the original table. These over here are called related columns because they are brought in through a relationship. For folks that have worked with DAX before, you may have noticed there is a related function. The related function lets you use these columns over here, okay? Okay, but I digress. We're done with step 2. Gosh, we're more than halfway done. The next bit is now that we performed the mega lookup, right? We've got all these columns in here. We're going to apply each filtering table, right? Let's break this out into sort of the 2 steps involved in there. For each filter, for each filtering table in the filter context, right? And there's only one, so we're just going to do these 2 things once. The first thing that's going to happen is we're going to check for matching column names in the target table, and then we're going to use the values of the filter table as which rows do I keep. Okay. All right. So we just got the 1 right there. Are there matching? Are there matching columns between these 2 tables? Yep, they both have a column called dish type right there and right there. There we go. So it's going to filter on these. Sort of a natural join for the SQL folks. So what does it do with a filter? Well, we're going to keep all the rows where the dish type equals regular. So anything that isn't regular, we're going to get rid of. So we're going to get rid of all the house special rows. They're all going to go away, just like that. There we go. Now, if there were more filters in the filter context because somebody clicked on one of these gluten-free options, I'd do that same thing for the second filter, but we just have the one filter, so it's only going to do it once. And with that, we are all done with filtering. Okay. Home stretch, step 3 complete, last step. So now that we've done that, we're going to aggregate the sale amount in the new table. So here's the new table. There's the sale amount column. What do we do with it? We're going to sum these values up. 20 plus 10 plus 12 plus 20. Let's see, 20 plus 10 plus 20. That's 50 plus 12 is 62. And sure enough, what do we get? $62. And that is how the sum function produces that $62 right there. Okay. Okay. Questions about that? Right. Okay. This went nice and smooth. It also went quite a bit faster than I thought. So we're done fairly early. So that's it. A surprising amount of work for a simple calculation. Got a few more things here that we could cover. So what do I want you to take away? Well, this is what I showed you at the very beginning of the presentation. And I want to show it to you again, right? So I said at the beginning, aggregation work with copies of the raw data. So you're always working with these copies. Relationships allow for a mega lookup to essentially VLOOKUP columns for filtering into the copy, adding these guys down here. Filters in DAX tables, or filters in DAX are just tables whose rows act as a list of values to keep for a given column. So if we've got a filter for dish type equals regular, it'll filter based on those common column names. And that final sum or min or max or whatever is going to get applied to the final filtered copy. Okay. Questions about that? Okay. Okay, well, why does this matter? Who cares, right? I will say that most users tend to quickly focus on the raw tables in the data model because they're visible inside the Power BI program. So when you open up Power BI, you could go over to the left-hand side and see tables that look like this. And when you do, new users become kind of obsessed with them. And I understand why, right? Oh yeah, I'm summing up this column or this column over here. However, all the work in DAX does not get done on these original raw tables. It gets done within the copies, or we can call them table values or temp tables, whatever you want to call them. So all the work gets done on those copies right there. So getting used to visualizing these copies of tables early on is going to help you understand what is happening within any DAX code much, much, much sooner. This is going to let you start reading DAX code and see what's happening very quickly. And if you can see what's happening, DAX becomes much easier to work with. I call this skill of being able to look at DAX code and see these copies of tables or temp tables, table vision. It is the ability to look at code and see tables, and it is, I will make this claim, the single most important skill inside of DAX. If you could see the tables involved and what's happening with them, DAX is very easy. If you can't, it's damn near impossible. DAX is actually not very complicated of a language. It's much simpler than you think, much, much simpler than SQL. But if you cannot see these copies of the tables, the temp tables in your mind's eye, the simplicity will be impossible to see forever and ever and ever. As soon as you start being able to see them, you can start to see that simplicity and get really good at it. Okay. All right. So questions or comments? I have some questions of my own if you guys don't have any. Okay, so some questions that I was expecting people might have, even if they're too shy to ask them. Brian, what does it look like if I have a filter, like a slicer with more than one item checked? These filters, are they always exactly one column by one row? No, like let's say I've got a filter where I've got dish and I select burger and salad. The filter just looks like this. And we're basically saying dish type can be either one of these values, either burger or salad. So the only thing that gets knocked out in this case is pasta. So it's perfectly acceptable to have a filter that has lots of values in it. It's actually very, very common. So with DAX, if you've got like a number slicer and you go the numbers between, I don't know, 20 and 80, if you were to look at the filter that it produced, it wouldn't be greater than this number and less than this number. It'd literally be an enumeration, every single row between 20 and 80. That's how that works. Seems like it'd be really slow. It's still actually really, really fast. Okay. And I got one more. Hey, Brian, can filters have more than one column? Yes. If you're writing DAX, it's pretty easy to do this, but you can even see it within the user interface. So if I create a hierarchical slicer where I've got a shift and then dish on it, right? I can select and say, I only want to see the pastas that were served for dinner, and I only want to see the burgers that were served for lunch. This would create a temp table or a copy table filter that looks like this. And we're saying, I only want to keep the combinations of these two things. So it's not just, is it burger or is it salad? Is it lunch or is it dinner? The row has to be the combination of lunch and burger, or the combination of dinner or salad. Anything that isn't one of those combinations is what gets knocked out, right? Very, very common occurrence. Simple filtering. For the very technical folks in the room that are saying to myself, hey, Brian, isn't there some concept called lineage that you should be mentioning? So in general, the best way to think about this filtering is that it matches on the names of these columns here, right? Technically, there's actually an internal name that DAX uses to do that column name matching, which is called a lineage tag. If you open up DAX Studio, you can find them. They're about 4 pages long each. It's a big random string of numbers and gobbledygook. However, you have to work pretty hard to get behavior that is not exactly the same as it matches on the fully qualified column names. You could do it if you go look at the Italians book. They'll show you an example of it, and you look at it and you say, I would never do that, and you're right. You would never, ever do that, but it is technically possible. Okay, hey, we got a question out there. So
yeah, we've got several actually. So Teresa, who's calling in from Missouri, actually this evening, she asks, if you have thousands of rows in your fact table, any ideas to validate if the table filtering is processing correctly for the formula?
So the question is, let's say that I've got, I have a higher number of unique values, right? So instead of just 20 to 80, it goes from 20 to 80, but it's in pennies, right? And does it actually have all 6,000 values? The answer is logically, yes, it does. The data is set up in such a way. Well, let me get this. I'll start by saying, yes, it does. The data is set up in such a way that actually evaluates very, very quickly. The other thing is, the only values that show up are the ones that actually appear in your data. So usually you're not going to have sales transactions that represent every single unique combination. There will be a lot of buckets in there. However, it will only be those values that actually show up in the data that will get represented, which is also why sometimes too with the slider for the between values, like you'll slide and you'll get funky answers. That's because it's matching to the closest number that is actually in your data, because it has to be, it's not a where clause. It's literally just, it's finding a range of values in your data to keep. Okay, yeah, and it's because DAX is a column store database and is compressed very well and is optimized for this kind of thing. All the stuff that I'm talking about, stuff that would make a regular row store database's DBA heart attack, they'd fall over. They say, "Good God, what are you doing?" All this stuff works really well, which is one of the reasons that DAX is both confusing and also really charming. Seems like it should be as slow as you could possibly imagine. Actually, it runs very, very fast. Set operations kind of overlapping that inner join stuff or the semi-join stuff I was talking about. Hey, that database is optimized for it. It is way faster than a where clause, right? Good.
Okay, and there's so Carol is asking about the temp table, and you mentioned being able to visualize that in your mind as an intermediate step in understanding what you're going through. So she's asking, is that accessible? Where could it be viewed? Is it available?
You can view it in my Elements of DAX series on YouTube. So the bad and the good news is there's no evaluate formula button in DAX. In fact, I was at a conference many years ago. It was gosh, what was the name of it? The Business Users. It was like one of the first big Power BI conferences, and somebody asked, I think they asked Alberto that question. Hey, is there where's the evaluate formula button? And he's like, there's no evaluate formula button. So that begs the question, Brian, you just told me these are the most important concepts in DAX, and I asked, where can you see them? And you say you can't. Yeah, that's why I went through a lot of work to build this video series. So if you work with DAX long enough, you'll figure out how to see these things. I think I don't want to toot my own horn. I think I'm the only person that I know of that explicitly does this stuff where I represent these table values or these temp tables visually in Excel, which is why I'm going to promote my own stuff. But I think it probably is the best way to do it, or at least when you are working through other people's books, do your best to think about these copies. And they're not wildly complicated. I've just shown you like 2/3 of them are literally get copy, add all the columns, and filter, right? The only other really complicated thing that happens is grouping, where you say, okay, now that you've got this copy, I want to go get all the combinations of shift and type and make that into a smaller table and do grouping like you would do in SQL. Other than that, it's not incredibly complicated. I've shown you most of it right here. So I don't mean to self-promote, but I think the Elements of DAX video series is quite good. Also, I've got some videos on these DAX sketches that you'll find on our SkyPoint YouTube channel, which also shows the stuff. It's not that I don't think anybody else out there hasn't done it. I just don't know of other folks that routinely do it, right? Mm-hmm. Not this explicitly anyways. So that's me in shameless self-promotion mode. Sorry about that.
No, that's great. Thank you, Brian. And then Brad, I'm not sure if your question, because of your comment afterward, I'm not sure if this is still an open question for you or not, and you can speak up and raise it if you want to.
No, what he said makes perfect sense to me. So
okay.
So thank you.
Okay. So it's answered.
Cool.
Very good.
I'll take it. I think I got one more, maybe. Raul, you got a question?
Yes. Well, just comment. You could also, but would you turn on the performance analyzer and kind of see how it kind of flows through that kind of the series of logic to get to the table?
So you could open the performance analyzer and you could go extract the DAX query from it. It will help you with the parts of the part of the presentation that I didn't talk much about, which is, Brian, you say that you click on this slicer and it produces this filter that looks like this. I'm basically just waving a magic wand. If you look at the DAX code, it'll show you how you generated this table right here. It does a good job of showing you that. The other stuff, because it's usually encapsulated inside of a measure, it doesn't help you very much. Another thing you can do, here's a good example, right? If you want to practice with DAX, you can go to DAX Studio, which SQL BI has this program called DAX Studio, which lets you run stuff. Technically, the output of DAX Studio is what I call a summary table. They call the output of a DAX query, both perfectly good names for it. But if you use variables in your code, you could squeeze these table copies, these temp tables, into variables and say, I've got like a 6-step calculation. I want to put the first step in a variable, and then you can actually load the variables in DAX Studio and see kind of one step at a time. Does that kind of make sense a little bit at a high level? Yeah, it's a great idea. Thank you. Yeah. The other thing I do, and this would take a whole hour to show you how to do it. But I'll mention it. There's a function called concatenate x, right? And what concatenate x does is, rather than summing up a column, it concatenates all the values, right? So what you could do is you could take one of these table copies and run the concatenate x function to generate essentially a text string that looks like a table. So what you do is, for each row, you go print out all the values of that row, and then the delimiter for concatenate x, what it puts between each row, you type in unicar 10, which is a line break, and then when you look at it in a visual, it'll actually show you all the rows. I might even be able to show people something like that if you want to, or we could say, no, Brian, you've talked about way too much stuff already. I'll take your word for it. How are we feeling? We feeling pretty good?
If you can jump right into it, there is time.
Sure, yeah. So let me...
There's concatenate X. Is there a regular concatenate, or is this a special kind of concatenate? I'm just curious.
Yeah, so the title of this presentation was the basic aggregators. So I skipped all the X functions, right? So there's a piece in the middle that I'm missing right here. What the X functions let you do, let me show it to you real quick before I go all the way in. So let's see, where was I? Let's come back here. Let's I won't full screen it. So let's say instead of trying to figure out what the total sale amount was, you wanted to figure out what the total cost was, right? Well, we have a column over here called cost per, and we have a quantity. We don't have a total cost for our line, but if for every single row we multiplied the number of things that we sold times the cost per dish, we would get one number for this row, one number for this row, one number for this row, and one number for that row, right? if you wanted to sum up those hypothetical numbers, you could use a function called sumX to say, I want to go get a temp table that looks like this, or a table copy that looks like this. And for each row, get that row's quantity and multiply it by its price. You'd get 4 numbers and you'd sum them up, right? That's the basis of a X function. It allows you to basically calculate a new value for each row that isn't in the table as it exists, and then sum it up. Concatenate X lets you do that, and you define what is the text string that you want to do for this row, for this row, for this row, and for this row. And then it will concatenate them all with some Unicode character in between, a delimiter, right? Okay.
Yep.
So I just worked myself into a second example, right? You guys thought you were going to get to go home early. I'm sorry. I'm going to hog the mic here. So let's go do that one first, right? So where was I? I'm going to go to my main page here, and I'm going to duplicate it because I can. So let's go do the total cost calculation, just so you can see what that looks like before I show you concatenate X, okay? So I'm going to add a measure. Total cost, right? There's no cost column. I can't sum it up. What I can do is go get, in fact, I'll do it to you this way. I'll show it to you this way. 1, 2, 3, 4. We're going to go get a copy of the sales table, right? And we're going to put it in the, not the concatenate X function, that's my next example, the sumX function. Okay, so this is going to generate the copy that we can write a formula to run once per row. Well, what's the formula that we want to run once per row, or what I call the per row formula? That's this guy right here. For each row, I want you to go get the quantity sold, and I want to multiply it by, we alt tab over here, each row's cost per. Now, I said before, these are native columns and these are related columns. I can use the related function to go grab these values. So if I go try and type dish cost per, it'll give me an error if I try and run it, right? However, if I type in related, hey, look, there's the list of all those columns from the dish column. Cost per, there we go. So now it's going to take this argument 2, the per row formula, and runs this once per row. So it's going to take 2 times 4 is 8, 1 times 4 is 4, 1 times 6 is 6, and 2 times 4 is 8. And if I was good at math, I would tell you what that sum was, but I don't have to because I can add it as a card over here. $26. Okay. Ooh.
No, I'm just wondering why you have to actually explicitly specify that it's related. Doesn't it just know because of the many to one lookup?
My
or is
honest
it because,
answer. Go ahead.
Sorry?
I think it's to, this is my guess. I'm not Jeffrey Wang. I did not build DAX. My guess is it's to avoid confusion when you're writing your formula, right? Because once you type in related, if you've got a big model where you have 200 related columns, you start typing in your formula, IntelliSense pops in every single column you've ever heard of. What gives? I thought I was writing code that went over the sales table. I'm not sure why I have access to dish cost per. This is basically just trying to make people not lose their minds when they start writing this formula. I don't think it's performance. I literally just think, and I don't know, maybe I'm wrong. I think it's literally just not to confuse people.
I'll look it up, but that's interesting. Okay.
Okay. So far, so good?
Yep.
Okay. So for my next trick, we're going to use some DAX to attempt to simulate what a temp table looks like. And to make my life just a smidge easier, I'm going to focus on this dish table here. Okay. I'm going to right click. I'm going to do new. And I'm going to call this show me dish. Right. So what I'm going to do is I'm going to do concatenate X. And I'm going to go do dish. And so this is going to get a copy of dish. Right. It's going to attempt to do that mega lookup I was talking about, but the lookup direction doesn't go in this direction, right? I can look up from here to here, but not from here to here. Does that distinction make sense? Okay, so when I perform the mega lookup, I get no additional columns. There's only 1, 2, 3, 4 columns, right? In each one of these doohickeys. It's a technical term, okay? All right, so now I write my per row formula. What do I want to do? Well, for each row, I'm going to go get the dish Let's do the dish, and I'll put a little space between them, and I'll do dish, the type. That sounds pretty good. I'll do a space between them, and I'm going to do dish, and let's go get the gluten-free option, and let's do, oops. Fancy keyboard makes for lots of mistakes. And dish, cost per, okay? So for every single row, I want you to construct a text string where you get that row's dish, put a little space, get that row's type, put a little space, put that row's gluten-free option, put a little space, and put the cost per on there, right? And then what do I want to put between them? Well, for now, just to make things not pretty, I'm going to put a little pipe between them, just so you can see it, right?
Yeah.
Okay. Now you can't add these to a card. Well, actually, you might add them to a card. They work way better in a table. So I'm going to take a table visual. I'm going to drag in show me dish, right? And we can see that if we click on regular, it's got sort of what I said. It's got the name, the type, gluten-free, and the cost, and then a pipe between them. Yeah, that's good, but I want it to have like a line break between them. Well, I got a trick for that too. And if you've seen some of my videos, you are probably tired of me using this trick, and that's okay. There we go. And so now if I click on how special, I can see the how special rows. I can click on no and just see the no rows, or I could click on yes. I could click on yes and also click on regular, and I could kind of render out what those tables look like. It's a lot of work, but it's kind of a fun way to do it. DAX Studio, I think, is the more efficient way to do this. But it's a nice way of testing your skills, right? If you can really see these tables in your head, like I can after doing this 10 years, right? Writing formulas like this is a breeze, and they look really cool too, right? Hey, Brian, I hate that 6 is not $6. I want it to be, because it should be a money thing. I want to render it like money. There is a function called format, and this uses a good old Excel style of formatting strings. There we go. And there we go right here.
Yep.
Okay, there you go. Okay, so that's it. That's sort of how you could do that stuff. One of the ways I use this concatenate X is to enumerate tables like this. I use this trick a lot, though, to generate a table. People love seeing stuff like this, where I can generate, like, in a single cell, like multiple rows listed out like this. Gets oohs and ahs every time. So worth experimenting with, playing with. Any other questions? Brian, can you debug my theme? No, probably not. Well, maybe, I don't know, but not in the next 5 minutes, which is when everybody wants to leave, because it's you know, it's late, right? Anybody
That's
else?
a common question.
What? Yeah, that's right. Yeah.
Okay.
Going once.
Yeah. Very good. Well, thank you so much, Brian, and thanks everyone for attending tonight. And we'll get the word out about our upcoming meetings, and we hope to see you at our future meetings, both of the Bay Area Power Platform user group and also the Bay Area Microsoft or Azure Data Platform group. Thanks, everyone, and have a great evening.
Thanks so much for joining, folks. I had a really good time.
Thanks, everyone.
Thanks, everyone.
Thanks.